Hello guys, welcome back, and in today's video we will discuss about the rates of reaction of your RGCSE physical chemistry chapter. Alright, so in this video or in this chapter, what you would learn is what makes a reaction faster or slower, and what are the factors that makes a chemical reaction faster or slower. Okay, so some of the factors that is generally pointed out are changing the surface area, concentration, temperature, pressure, and the catalyst. So in this part 1 video, we will discuss about changing the surface area and the concentration first. Now, the rate of a chemical reaction is the speed at which either the amount of your reactants decrease or the amount of your products increase. Okay, so in a chemical reaction, your reactants will be used up naturally and you will be forming products, but the speed at which these reactions are happening is called the rate of reaction. So it can be change in concentration or volume or mass over time. So the units can be different from time to time. For example, if it is change in concentration over time, it could be mole per dm cube per second. If it is volume, it can be centimeter cube or dm cube per second. If it is mass, it can be gram over seconds. Now, let's try to investigate the rate of reaction between calcium carbonate marble chips and dilute hydrochloric acid. Okay, let's take this as a base case and try to understand everything. Okay, so the equation for the reaction is when calcium carbonate reacts with hydrochloric acid, you will produce calcium chloride, water, and carbon dioxide. The laboratory experiment for this will work like this. First, you have marble chips in a conical flask and you will weight it and reset it at 0 grams, and then you're going to pour a fixed amount of dilute hydrochloric acid into calcium carbonate, and a reaction will take place inside here. And you will notice that instead of increasing mass, the mass will be decreasing. So what does the negative mass mean? So the negative mass means that the mass is reduced, or negative mass, because one of the reaction products, which is carbon dioxide, a gas, is going to be escaping, okay, through the conical flask here, and that is why your mass is decreasing, and the rate at which your mass decrease will be plotted against time, and we will see the rate of the reaction. But here, a very commonly asked question is why do we use a cotton wool? Okay, let's take a look at this. You will notice that we're using a cotton wool here. Alright, the reason is that because the cotton wool will provide any acid from spilling outside, but then it will allow carbon dioxide to escape the conical flux so that we can actually measure the reduction in mass. Okay, so when we are looking to calculate the rate of a chemical reaction, and we're going to divide the mass of carbon dioxide produced by the record that we have here at every time interval and divide it by time. So let's try to do a few examples here. Alright, so in here, the rate of reaction in the first minute would be around 0.47 grams divided by 1 minute here. So your reaction rate would be 0.47 gram per minute. In the same way, let's try to look at the reaction rate in the second minute. So in the second minute, you will notice the reduction of carbon dioxide to be around 0.67 minus 0.47, okay? Divided by, since it is another minute, it is still 1 minute. So you will get around 0.20 grams per minute as well. So the total reaction rate over the first 2 minutes would be roughly around 0.47 plus 0.2, which would result in 0.67 grams per minute. And let's try to read the graph a bit here. Okay, so we notice here that if the gradient or the slope is steeper, as we see in the first half of the graph, it means that the reaction is very much faster. Okay, so a lot of carbon dioxide is being produced in the first minute here compared to the second minute here, where lesser carbon dioxide is being produced. And you might think that is it not that 0.7, so carbon dioxide is being produced faster in the second minute? No, because we're looking at the rate of a chemical reaction, so we are only going to see the difference here. All right, so there are different laboratory methods to measure the amount of gas. Sorry. For example, by using a side-on flask collection method, what you can do is that when carbon dioxide or CO2 gas is being produced here, as per our reaction, how it can be collected is by using a gas syringe. So as gas is being produced here, your flask will increase, the syringe reading will increase. So the gas will come over here and you will start to collect a few here, and it will continue to increase. Okay, and we are going to measure it with respective time. Okay, so this is another way to collect carbon dioxide gas or any gas as well. But make sure that you are understanding that when we are trying to measure the rate of a reaction, we are always measuring volume and the time. Both of these need to be recorded at the same time. Now, collision theory. Okay, let's try to talk a bit about this. So in order for any chemical reaction to take place, any chemical reaction that you have learned before, they are happening because particles are colliding with each other. But then again, not all collisions cause chemical reactions. Some just bounce off each other. For example, let's take a look at this here. All right. So when we say that the particles are colliding with each other, it's the H plus ions and CO32 minus ions. For example, from calcium carbonate, it is the negative ions such as CO32 minus ions. From HCl, it is the positive H plus ions. So these particles are colliding with each other. You cannot say that HCl and calcium carbonate molecules are colliding with each other. Okay? So in order for a chemical reaction to take place, now the particles have to collide with a minimum amount of energy called the activation energy. Now if it is not the activation energy, a chemical reaction will not take place. They will just be bouncing around each other. So collisions which have energies greater than or equal to the activation energy are what we call successful collisions. Okay, so let's try to take a look at the graph here as well. Now in here we can see that in the early reaction, the reaction is very fast because a lot of the acid particles are colliding with the carbonate chip. But later in the reaction around here, the graph is becoming shallower, meaning that the reaction rate is becoming so slow. It is because the H plus has been used up. Because calcium carbonate, remember, it is put in excess. Alright, so from HCl, the H plus ions are being used up, and that is why there will only be fewer acid particles, meaning that there will not be a lot of successful collisions. That's why the reaction becomes slower at the very end.